showing you IAM privilege escalation attacks in AWS. That's what I spent my semester doing research on. So the problem with IAM, to start with, is it's way overly permissive in a very easily manner. IAM is how administrators in AWS are able to distribute permissions and gives users or services the ability to do various things. And poor configurations on the administrator's part can lead to privilege escalation attacks, and that can lead to further things like exfiltrating PII or other private data. And it's really difficult to stop this because AWS sometimes can be very intricate, very large, and that's something I wanted to investigate. And during the semester, I said I wanted to write a white paper that goes ahead and captures the various attacks and mitigations that I'm going to show you shortly. And just a quick sequence of events through this presentation. I'll show you an EC2 and CLI based attack and how I was able to mitigate them. And then we'll talk about the Capital One IAM breach case study and PM Mapper IAM analysis tool. So to start with, the AWS CLI attack. And so we have an attacker, and they currently have this policy. And at the bottom, you'll see the attach user policy, which is what makes this user vulnerable and how they can leverage higher level permissions that they aim to gain on their AWS account. And so the attacker pretty much is able to generate these tokens that they're able to authenticate to the CLI from. And so once they do that, they can say, all right, well, let's see what policy I have now. Right now I have the attacker policy, which is pretty much right here, what I showed you before. And so we're going to look real quick at the policy for administrator access, which is what an admin has and what the attacker aims to gain, which is unrestricted access to everything and anything within AWS, really. So continuing on with the attack, they can do a grep on all the different permissions within IAM, and like I said, we'll pick out the administrator access one, grab its Amazon resource number, and keep going. And we will go ahead and attach it to the attacker. And then we can run a command that pretty much lists out all the currently attached policies to the attacker and show a proof of concept that a privilege escalation attack has succeeded. And now the attacker is free to, they can do a lot worse. They can remove resources, they can modify them, delete users, anything under the AWS sun, really. And so to stop that, I wrote a little script that goes ahead, and we will see which users are supposed to be having the administrator access permission. And so this script pretty much checks, do they have additional permissions beyond that? And then we know that they broke the rules. They are the attacker user, and we'll go ahead and delete them. And so moving on, we will move into EC2, which is virtual VM, so to speak, that AWS offers. And I started out by writing a CloudFormation template that pretty much is going to put the EC2 attacker role, which I created to have unrestricted S3 access. S3 is a storage service in AWS to put various files. And this YAML code on the left will go ahead and build an EC2 instance with this role attached automatically. And so an attacker can go ahead and say they want to read all the information from this S3 bucket that has employee personally identifiable information. And so all the information is here, and so they pretty much just grabbed this file right here and read all of its contents and conducted a privilege escalation attack strictly through code. And so now I'll go ahead and show you a quick little mitigation. We can go in and generate logs. We can see what's the attacker's IP address, something identifying about them, to go ahead and try and stop them or some subnet from doing this again. And we can match the IP address here from the instance that I built from CloudFormation in that YAML code. Over here, you can see they tried to go into this bucket, time-stamped, and they were successful. Now we'll go into a case study. Capital One had an IAM breach, and an attacker pretty much used these tools to obfuscate her identity to gain access to a web application firewall that was underneath an EC2 instance to read from a private S3 bucket. and there were two potential IAM roles, one that had S3 access out of the box and one that did not. So we'll show how the attacker was able to get that information from the S3 bucket illegitimately. And so this command pretty much outputs all the metadata that the EC2 instance has, and we can generate a security token from it to go ahead and say, all right, now I want access, I can give it to myself. EC2 instance is able to generate these tokens to kind of do whatever it wants. It's overly permissive by nature. And in this case, we'll see now we're going to attach another EC2 role that is more permissive than the one we currently didn't have. So this one's a little tighter than the previous screenshot, but we can still leverage another permission set through just attaching another role based off its ID that does have S3 access. And so when we do mitigations, we want to make sure we definitely do not use quad zeros. It's in the first bullet that we make sure inbound and outbound rules are for specific hosts, and not anybody and everybody can read from our S3 buckets, which might be behind this security group. And we try to also apply least privilege. They should not be reading buckets that web application firewalls have no business reading. And we definitely do not want EC2 instances attaching roles that they shouldn't be. Whatever we plan to give them out of the box is hopefully what we intended for them, and nothing more or nothing less. So I also found this cool tool. It's called PM Mapper, and it pretty much takes in your AWS account, and you can give it cool little scenarios. Like in this case, I wanted to read who can download and see the contents of the pii.txt file. And so now I can see all the users that actually can read from that file. And it's obviously overly permissive. I have all the accounts under my AWS account, or users, I should say, under my AWS account that can read from it. So we definitely want this output to be a lot smaller. We do not want saved users or EC2 roles reading from private S3 buckets. It really should just be the 3 admins up top. And so we can also do this for IAM. We can say, all right, who can create users in the AWS account? And so this shows a little tightened up in terms of who can actually access these things. And the attacker is still there, but the safe users are gone. So now this shows that we still have a little bit of work to do, but this permission is a little more locked down, which is great. And so the evaluation from this semester and my work so far is there's a lot of automated tools or just bash scripts that we can do around cron jobs to execute a lot of the information that we aim to find. And just a general proof of concept that these slight little permission mishaps really do have a catastrophic effect, and it can be hard to find them. AWS can be very versatile, and if you're a big company like Capital One with millions of customers, millions of people were compromised their information through that attack, it can really be hard to identify what service is really vulnerable. And I covered the following 5 services: EC2, CloudFormation, S3, AWS CLI, and the web application firewall. So we kind of got a cool gist of the different ways to attack IAM from tools that just do different things. Limitations to this attack: it's definitely hard, like I said, to look at all AWS services an organization is using. I mean, take a company like Netflix. They use, pretty sure, a bunch of AWS services to service pretty much the whole world. So it's hard to find when there's gaps in IAM that we need to locate. And in my specific attack, I used the CloudFormation stack, and the limitation in that respect is we can't stop the stack from building because I attached a overly permissive role very easily. You'd have to let the stack finish, and then we could go ahead and delete it afterwards. There are a lot of custom scripts you can try maybe integrate with, but generally out of the box, it's hard to send signals to CloudFormation to kill that script. Specifically just off IAM roles, those signals look for other things, like other resources just haven't been set up yet, which is not really what we're doing here, so that is difficult. Future work, I definitely want to automate a lot of this stuff and use other AWS tools like CloudWatch, where we can write custom alarms that trigger when certain thresholds are set. Say a new user was created, set off an alarm, or a new user was created with the administrator access permissions, set off an alarm. And that way administrators can have these things come to them instead of them having to run scripts manually. in the event of using logs, we can use a tool like Splunk to write queries and save a lot of time to find these users themselves. And we can automate a script that pretty much runs these queries over and over and over again on our logs to constantly try and find users if an administrator doesn't want to go and download it like I did 10,000 times a day. But that's it, and thank you everyone for watching.